Today we're going to start Unit 2, which is talking about quadratic functions, and we're going to begin with vertex form of a quadratic function. Okay, so what we have here at the top is called our vertex form. This f of x equals a times the quantity of x minus h squared plus k. This is vertex form of a quadratic function. So, and from this form, we can find a few different things. We can find our vertex, which is hk. So, for example, if we were looking at this graph here at the bottom, if we were looking at this graph, our vertex is this top point on our parabola. Remember, this is called a parabola, this U shape. And our vertex is positive 2 from inside the parenthesis and a positive 3 from outside the parenthesis. Then we're also going to find our axis of symmetry, which is x equals h. So on this example, our axis of symmetry would be x equals 2. That's talking about if you were to draw an imaginary line here at x equals 2, if you were to fold that parabola, you would have the same thing on each side. So from this vertex form, we can figure out a few different things. So the first thing that we can look at, and we talked about all this when we did transformations, is this number inside the parenthesis, the h that's in the blue. This will tell us if we're moving left or right. And remember, these are the opposite of what we think it should be. The k, the one here in the green, the one outside the parentheses, tells us that we're either going to move up or down, just like when we talked about transformations. The number out in front, we said before, is going to tell us if it's skinny or if it's wide. But it also tells us if it opens up or down. That's our flip. So example 1 says, describe the transformation of the parent function f of x equals 2 times the quantity of x minus 3 plus 4. And like I said, we've talked about this before when we did our transformations. So the number inside tells us left or right, and it's the opposite. So that minus 3 tells us that we're going to go right 3. The number on the outside tells us up or down. So the plus 4 tells us we're going to go up 4. The number in front tells us skinny or wide. If it's bigger than 1, it's skinny. And then since all these are quadratics and we have that U shape, we're going to talk about if they open up or down. If it's a positive number, like positive 2, this is going to open up. So example 2 says, identify the vertex, the axis of symmetry, the maximum or minimum, the domain and range of the given function, and sketch a graph. So we're going to use what we know about transformations and domain and range that we've all done in chapter 1 and apply that to quadratics. So we're going to look at this function, y equals 3 times the quantity of x plus 1 squared, subtract 3. So just talking about transformations like we did in example 1, this number on the inside is going to tell us that we're moving left 1, because remember the number on the inside is the opposite of what it seems. And this minus 3 is going to tell us that we're going down 3. Well, that's what we need to get our vertex. So if we're going left 1, that would be negative 1. Down 3 would be negative 3. That gives us our vertex. Your axis of symmetry is always going to be x equals the x from your vertex, which is always this first number. So our axis of symmetry is x equals negative 1. Now, before I answer the rest of this information, I'm going to go ahead and start sketching my graph. So I'm going to start with my axis of symmetry, which was x equals negative 1. So I'm going to go to negative 1 on my x-axis, and I'm just going to draw a dotted line. Straight down, x equals negative 1. Then I'm going to sketch my vertex, put a point at my vertex, which is -1, -3. Now if I come back up to my equation, this number is positive 3. So first off, it's going to tell me that my graph is skinny because it's bigger than 1, but it also is going to tell me that my graph is going to open up. So when I sketch this parabola, this bottom point is going to be my vertex, and I'm going to open up. It's going to be a little bit skinny, and that axis of symmetry is going to tell me that if I were to fold this blue parabola on that red line, they should match up each side. So now since my parabola is opening up and my vertex was this bottom point, that means I have a minimum. My vertex is a minimum. Then I'm going to talk about domain and range, just like we did in chapter 1. So domain always is our left to right, which is our x values. So as we go to the left and to the right, notice we have arrows there at the top. So that tells us negative infinity to positive infinity. Your range is your bottom to the top, just like chapter 1. So we do have a bottom point here because we set a minimum. So our vertex is our minimum, and our y value is -3. And it goes all the way up with the arrows, which means it goes on forever to infinity. Okay, example 3, same type of question as example 2. Identify the vertex, axis of symmetry, maximum or minimum, domain and range, and then sketch your graph. So let's start by looking at the equation and talk about our transformation. So this -4 inside tells us that we're going to go right 4. And this +7 on the outside is going to tell us that we're going up 7. Well, that's what we need to get our vertex. So our vertex is right 4, so +4, up 7, so +7. The axis of symmetry is always going to be x equals your x value from your vertex, which is the first number. So x equals 4. So now let's start to look at our graph over here. So if our axis of symmetry is x equals 4, that means you go on your x-axis to 4. Draw a vertical line straight down. That's going to be where we could fold our parabola. Our vertex is 4, 7, which is going to be a little bit off the graph, somewhere up here. So if we come back and look at this front number, first off, it's a negative, which means that our parabola is going to open down. And since our number is less than 1, that means it's going to be wide. So when we sketch this, we're going to have a parabola that's a little bit wider, and it's going down since we had that negative. So since it's going down, that means our vertex up here is a maximum. So domain, once again, is your left to right, your x value, left to right. If you come out to the leftmost point, notice you have arrows. For rightmost point, you have arrows. So negative infinity to positive infinity. Range is your bottom to top. So your bottom, but notice there's arrows. So negative infinity. You have a top, since you had a maximum. That y value at the top is 7.